Hello everyone, I am Sendil Kumar, working as Assistant Professor in Sri Ishwar College of Engineering. This is a webcasting session for the subject Computer Network, and this is topic 1 where I am going to teach you the foundation of computer networks. Before going into the subject, what is meant by a computer network? Interconnection of multiple computers to perform some task or to share some resources like printers, computer networks is used. So in this subject and in this session, and I'm going to start from the foundation. So these are all the problems which I'm going to cover at this session, and after attending this session you are able to answer to all the questions. So these are all the few questions. How to build a scalable network that will support a different application? Today most people know internet, or most people know network only through application. So how to build a scalable network that will support a different application? The second problem is, what is a computer network? It is a very fundamental question, and you will be able to answer this question after few minutes. Now, many networks are there. Telephone network, many other networks are there. So how is a computer network different from other types of network? Then the last problem, what is a computer network architecture? So after attending this session you are able to answer to all these questions easily. So these are all the chapter outlines. First, in this video I am going to cover the different application that uses the computer networks, and I am going to discuss about the requirement the real world places on a computer network. In the next video I am going to cover about the next architecture. So our main focus on this video is to discuss about the application and to analyze or and to understand the requirements the real world places on a computer network. So application. So before moving into application, the first, let's assume you are going to build a computer network that is going to grow according to the client needs, and you are going to support a wide variety of applications ranging from World Wide Web to audio and video streaming. So how you are going to build this network? The answer is very simple. You are able to answer to these questions after watching all my videos in this series. Okay, now let's enter into the subject. So in this subject, I'm going to show you the various building elements or building components of computer network, and later I am going to show you, or I am going to teach you how to use all these components to build a computer network. Okay, so first, what is mean by a computer network and why this computer network came to our IT? Initially, during mainframe computer periods, the dumb terminals are connected to mainframe computers using a network. So that is the primary purpose of network in those olden days, but today we are using the network for many other purposes. So what makes the network, the computer network, different from other networks? Most of the other networks that is there in today are designed to handle one kind of data. But in case of our computer network today, most of our computer networks are handling multiple types of data. So what makes the computer network different from other networks? So the main characteristics of computer network is generality. So it supports wide variety of data. But if you take the normal network, then most of the normal networks support a one kind of data. So how it is possible? The reason is very simple. It is possible because most of the computer networking components are created using general purpose programmable hardware. So we are able to program these devices for many kinds of data. But if you take a telephone network as an example, in telephone network, the nodes are nothing but a small device. The main purpose of the telephone equipment is to transfer the voice. That's it. But in our computer network, we use switches, routers that are able to program to the user needs. So it is not possible in other network, but in a computer network, it is possible because all the devices that we use are generally programmable in nature. So the main characteristics of computer network is generality. Okay. Now we know the characteristics of a network, that is generality. Now how to proceed further? It is very simple. The first thing we need to know to build the computer network is understanding about the applications that you are going to use. Then after that you need to understand about the requirement that your network should satisfy. So these are all the two things you need to know. Fine. So after knowing the application and after knowing the requirements, how to proceed? So are you going to build a first computer? No. Already researchers gone before us and lot of improvements are there in our computer networking technology today. So we are going to just follow the networking architecture that is created by those researchers to build a computer network. So this is called a network architecture. So this network architecture is already created by these researchers. So we are just going to study the network architecture and we are going to rearrange this networking architecture or network architecture for our purpose. It's very simple. So building a computer network is somewhat easy now and you know the fundamental concepts. That is, first one is learning about elements or learning about the components that is used to build the network, then learning about how to use these materials to construct the computer network. Then you know the real purpose of the computer network, that is understanding about application, and the next part is requirements that the real world places on the network. Okay, now it's time to learn about application. Most people know about the internet only through applications. Today, we are using World Wide Web, email, online social network, streaming audio and video, file sharing, instant messaging, and unlimited number of applications that uses internet to work. So that is why most people know about the internet only through application. We are saying internet as a computer network, we can say, because a collection of computer network is called as internet. Okay, it's time to look into the classes of application. So the applications are divided into three classes. The first class is World Wide Web. So the World Wide Web is nothing but we are accessing a web page from a remote server. That is a primary purpose of the World Wide Web. So in order to access the web page that is stored in a remote server, initially in the first stage we are going to type the URL, that is called Uniform Resource Locator. The primary purpose of Uniform Resource Locator is to identify one particular resource from a web server. So as of now, to keep the things simple, I am going to keep the object or the resource as simple web page. So in our presentation, we have index.html, and this index.html resource or a web page is located in princeton.edu web server. and we are going to use the word HTTP. This is called hypertext transfer protocol. So this is one protocol we are going to use to download the web page. In the later sessions or in the later videos, I am going to teach more about this hypertext transfer protocol and URL. So as of now, our first class of application is World Wide Web. In order to access the World Wide Web, we require a URL, Uniform Resource Locator, and the primary purpose of this Uniform Resource Locator is to identify the resource from web server. Fine. And here we have HTTP. The primary purpose of HTTP is to download the web page from a remote server. Fine. According to us, accessing the web page is very simple. We are going to enter the URL in a web browser, and after typing the URL, we are going to press enter. Within a fraction of second, we are going to get the web pages. But the real things is not simple like that. Just in order to find the IP address of the server, you need to transfer 6 messages from your web browser to server and server to web browser. So what is mean by internet protocol address? It is very simple. www.cs.princeton.edu is the name of the server. This is for human understanding. But in a real world, the web servers are named using a decimal number, a dotted decimal number called IP address. So practically, it is not possible to remember the IP address of all those millions of web servers that is spread across the world. So that is why today we are using a concept called server name, and in the background we use DNS, that is a domain name server, to convert this real web address or the real name into this dotted decimal IP address. So just to find the IP address or just to find the IP address of the server, you need to transfer 6 messages. And after that, in order to establish the connection between your web browser and the web server, you require 3 message transfers. And after that, in order to start transferring the web pages, you require 4 messages. And after all, after completing all the works and after downloading all the web pages, in order to tear down the connection, you require 4 messages. So things goes complex like this, but as of now, I just complete at this step. So the first class of application is World Wide Web, that is primarily used to access web pages that is stored in web server. The second class of application is streaming audio and video. So this is a second class of application that most people use today. So what is that streaming audio and video, and what is the difference between the World Wide Web or accessing the web page, and what is the difference between these two? In a streaming audio and video, you are going to continuously download a stream of audio and video. But in the World Wide Web, you are going to access the web page, and after accessing the web page, your internet connection is going to stay ideal. But in streaming audio and video, the case is different. Say, for example, if you are going to watch a video for 1 hour, then for the next 10 to 20 minutes, depending upon your internet connection speed, your internet connection will be fully engaged. In a normal internet, if a few bytes or if a few bytes lost, then it won't create much problem, and still you are able to get the messages, the lost bits from your web server. But in the case of streaming an audio video, it is not possible. So if you miss a few bits or bytes, then it makes a lot of problem in real world streaming. So the main difference between the normal web page accessing and streaming and audio video is a straight continuous internet connectivity between your web server and a web client. Now, the third class of application, that is real world audio and video application. So what is that real world audio and video applications? The best examples are our Skype today. Skype is real world audio and video application. So now, what is the difference between the streaming audio and video and real world audio and video? The only difference is the streaming and audio video actually transfers the data continuously to your computer, and in you are going to play the video. It is just a one-way communication. But in a real world audio and video, it is a two-way communication where two people going to simultaneously use the internet in both the direction. So timing constraint is very important in this class of application. See, in streaming audio and video, if a few bits arrives late, it won't create any problem. For a few seconds, if internet connectivity is dropped, then it won't create any problem because you are going to start playing the video only after downloading some data or some amount of data. There is a threshold. So because of the threshold, you don't face any problem. But in the case of real world audio and video, so you require a very good continuity, continuous connection between your web server and your browser. So here in this class of application, the timing constraint is very important. So these are all the classes of application. The first class of application is World Wide Web. The second class of application is streaming audio and video, and the third class of application is real world audio video application. The best example is Skype and other chatting applications. Now we all know about the application that is going to run on computer network. Now what are all the requirement that real world places on computer network? See, you are going to develop a computer network, so knowledge about this requirement is very important to build a computer network. So this is an example of an application that shows a real world video conferencing system. The software name is Cisco WebEx Meeting Center, and with the help of this Cisco WebEx Meeting Center, you are able to conduct a meeting from different places. It makes your life simple. There is no need to travel to different places. You can conduct a conference between multiple branches by sitting in the same branches. There is no need to travel to different places. Now, requirement. So the requirement comes from three classes of people. The first people is application programmer who design the application that is going to run on your network. The second people is network designer who going to design a network for you. And the third person is network provider who going to manage your network. So these are all the three persons, and this three-person perspective is different. Application programmer always lists the service that his application needs. The best example are delay bounded delivery of data. So what is the delay bounded delivery of data? The application developer, or application programmer always requires his or her data should reach the destination within a specified time. Now network designer. So the network designer always require a cost effective network with shareable resources, because if it is not with shareable resource, the cost of designing the network will grow high. So let me explain about the shareable networks or the shareable resources after a few minutes. Now network provider. the main characteristics of a system that is easy to manage. That is a main requirement of network provider. The network provider always want a network that should be easily managed with less downtime. So these are all the perspectives, and from these three classes of persons, multiple requirements come to us. So as a good network designer, or if you are going to design your own network, you should satisfy all these requirements. So the first important requirement is scalable connectivity. So what does mean by scalable connectivity? See, you are going to develop a network with 10 nodes now. But after some time, if your client wants you to add more number of nodes, then your network should support it. At that time, it is not possible to create a new network for additional systems. So the first primary requirement in building a network is your network should be scalable connectivity. So what is mean by scale? It is very simple. A scalable connectivity, or the scale, is nothing but your network should capable of adding the computer nodes or nodes dynamically based on the client requirements. So that is the primary purpose of scalable connectivity. Now I am going to explain some of the common terminologies that is used in computer network. As you know, the scale is nothing but dynamic addition of computer nodes into network, that is called a scale. What is mean by a link? A link is nothing but the physical medium. The physical medium, this line is the physical medium that connects two computers. That is called a link. So the link is nothing but a physical cable. A physical cable may be a coaxial cable, or it may be a twisted pair cable that connects two computers is called as links. Now, what is mean by nodes? And nodes is nothing but the end devices that this physical link connects. In our case, in this picture, the nodes is computer, even the switch, the routers, everything is called as nodes. Now, what is mean by a point to point? If a two computers directly connected with one another, and if the data flows from one point to one point directly without any intermediate nodes, then in that case we can call it as a point to point. Then we have the term multiple access. So what is mean by multiple access? In this picture B, we have four computers. In these four computers we have only one physical link. So all these four nodes going to share this single cable, and this cable is known as a link, and all this going to share the single cable. This is called as multiple access. That is multiple access of a one single physical link. There are a lot of concepts beyond this. I will explain about these concepts later. Then we have a concept called switched network. So what is mean by a switched network? It is very simple. Just now I discussed about multiple access. So what is mean by multiple access? That is sharing the single physical link with multiple computers. That is called multiple access. Now switched network. The switched network is a technology that enables this multiple access. Now circuit switched. In circuit switched, the entire physical link is directly shared or directly used by two nodes, and all other nodes wait for its turn. In packet switched network, each and every computer uses the shared link, but based on packet by packet basis, not based on the circuit basis. A packet is nothing but it is just like our courier box. It stores some volume of messages and this packet travels through the internet. The store and forward is very simple. Each and every nodes like routers, switches or other devices stores the packets, and finally after getting all the packets it again start to transfer in this network. So this is the first requirement, that is scalable connectivity. And just now I discussed about the terminologies that is used in scalable connectivity. And these are all the few other terminologies that I would like to share with you now. So what is mean by a cloud? In this picture A, the cloud is, you can see the real cloud here. In this cloud, the internal operation of the network is actually hidden, and these are the nodes that forms a network or that implements the network that is completely hidden using the clouds. And outside the clouds we have a lot of nodes that uses this network. So in a simple word, we can say a cloud as abstraction of a network, that is we are hiding the implementation details of the network from end user. So that is called as clouds. And host is nothing but a system that uses the network is called as host. And we have switches. The primary purpose of switches to transfer the data from one area of a network to another area of a network. Then we have inter network. So what is mean by inter network? Here in our picture we have a lot of independent network. Each one is represented in a cloud, and all these clouds are interconnected using a small device called a router. So inter network is nothing but a collection of network that is connected with the help of a specialized device called a router. Then we have a host to host connectivity. A host to host connectivity is nothing but the connection between one host to another host in a network. Then we have address. Address is nothing but each and every host and each and every nodes in our network have one address to uniquely identify that particular node in a network. Then we have a process called routing. So what is mean by routing? It is very simple. In this example, the inter network is connecting but a collection of network. Say for example, if this PC is going to transfer the data to this PC, then how it is going to transfer the data? Through this way or through this way or through any other way. So this decision is called as routing. Then we have a three most important term, that is unicast, broadcast, multicast. It is very important term. Try to note this separately. So what is mean by unicast? So unicast is nothing but if one PC, if this computer going to transfer data to only this computer, that is if this host going to transfer only data to this host, then it is called unicast. Then we have broadcast. So broadcast is nothing but if this particular computer going to transfer the same data to all these computers, then it is called broadcasting. Then multicasting, it is very simple. If one computer going to transfer or going to send a data to a collection of computers in a network, then it is called multicasting. So, in order to understand more about the scalable connectivity, you require to know about all these terminologies. So, the first requirement is a scalable connectivity, that is, you need to or your network should be capable of dynamically adding all this or new nodes according to the client requirement. The next part, the next important requirement is cost effective resource sharing. The previous requirement, the scalable connectivity, comes from network operators because they require the scalable connectivity in order to easily add the new nodes according to the client requirement. So the network operator always require a scalable connectivity, and the scalable connectivity requirement is placed by the person network operator. Then we have cost effective resource sharing. So who places this requirement? It is very simple. Network designer places this requirement to you. What is mean by cost effective resource sharing? It's very simple. Here we have three computers, S1, S2, S3. In this side we have another three computers, that is R1, R2, R3. R1, R2, R3 are receivers and S1, S2, S3 are receivers. So totally we have six computers, but check here, we have only one common channel to transmit the data to S1, S2, S3 to R1, R2, R3. So how this is possible? So our cost effective resource sharing should ensure we use most of the resources in an efficient way. That is a primary purpose of cost effective resource sharing. In this example, we are not going to use 6 cable, but we are going to use only one cable to transfer the data from all these three computers to this receiving computers. So how it is possible? It is possible with the technique called multiplexing. So what is mean by multiplexing? So multiplexing is nothing but here you are going to combine the data from three different resources into a single groups of data, and you are going to transfer all this data in a single line. At the receiver end you are going to separate all this data and you are going to deliver the data to a separate computers. So what is multiplexing? Multiplexing is nothing but you are going to combine. See, the I am not going to explain you multiplexing in a more technical way because that is out of our scope now. We have a separate chapter where we are going to study more about multiplexing. As of now, try to understand multiplexing as in multiplexing we are going to combine data from different sources into a single group of a single collection of data or a single block of data, and we are going to transfer that block in a single cable to this device switch 2 device, and here in switch 2 we are going to demultiplexing. Demultiplexing is nothing but we are going to separate the devices and we are going to send the data to appropriate places. It is very simple. See, you are going to post a letter to your friend. So how you are going to do? So you normally go to your nearest post office and drop the letter in post box. And in the post box, like you, most of the people will deposit the letters in that post box. And finally, the person called a postman comes, opens it and puts all the letter in his bag, and the postman is going to carry only a one bag to destination place, and in the destination he is again going to open the bag and going to deliver the packets to individual persons. The same thing is implemented in our multiplexing. So how it is effectively. So we know what is mean by multiplexing. So how it is done or how to do this multiplexing. So we have a concept called synchronous time division multiplexing, that is STDM. In synchronous time division multiplexing, we are going to divide the time slots and we are going to transfer the data only on the time slot. It is very simple. Say in this picture we have three computers. So we are going to give 10 seconds to S1 to transfer the data, and we are going to give another 10 seconds to S2, and we are going to give another 10 seconds to S3. So each and every computer uses 10 seconds to transfer the data. So during that 10 seconds, the data from S1 comes here and the data passes here. After this, we have S2 turn. In S2 turn, the S2 transfers the data for 10 seconds. Again in S3 turn, the S3 transfers the data for another 10 seconds. So this is a concept used in synchronous time division multiplexing. That is, the time is divided equally and allocated to all the computers. Now, what is the main problem in this method? It is very simple. If S3 wants to send a data and if S1 and S2 don't have any data to send, still it holds the time. Still S3 needs to wait for its turn. So that is the biggest problem in this method. Say for example, if S3 has some data to send to R3 and S1 don't have any data and S2 even don't have any data, still S3 need to wait for 20 seconds to get its turn. That is the main problem of synchronous time division multiplexing. Then we have another concept called frequency division multiplexing, where the data is transmitted in multiple frequencies. I discussed about the major drawback of synchronous time division multiplexing. So that drawback is overcome in statistical multiplexing. How? It is very simple. Here the data is transmitted based on demand of each flow and not based on a predetermined time slot. So what is mean by demand of each flow? The new word. It is very simple. Here if S3 wants to send data and S1 and S2 don't have any data, then simply S3 sends data to S1 and S1 and S2, if they don't have any data, they simply stay idle. Okay, so this is really a cool concept. But what is the another problem in this technique, in this statistical multiplexing? If S1 takes 1 hour of time to transfer all the big data to S3, then what happens to S other systems? That is the biggest problem in the statistical multiplexing. It is very simple. If S1 and S2 and S3 are the three nodes, if S1 have some huge amount of data, at that time S2 and S3 don't have any data, so S1 start transmitting the data. But the size of the data in S1 requires 1 hour of continuous connection between the receiver and S1. Then after 5 minutes S2 have some data to send and S3 also have some data to send. Now what happens to the network? So here in this scenario, S2 and S3 have to wait for 1 hour. So this is not sweet and this is not a good concept. So how to overcome this problem? Yes, that is with the help of flow. So what is mean by flow? Here the messages is divided or packed into packets, and each system or each host is allowed to send up to allowable packets, that is called a threshold. After that it checks for the network, and again if there is no need for the common shared medium, then again it transfers the threshold of data. So what is this threshold of data? It's very simple. Here our S1 sends, some fixed size of data. Say for example it sends 10 KB of data, then it again checks if any computer wants to send data. If any computer wants to send data, then it hand over the control to other systems. If there is a no computer, if there is a no need for shared medium, then again it sends another 10 KB, then it wait for its again and again the process continues. So these are all the technique implemented in statistical multiplexing that provides an effective, a cost effective resource sharing. The next requirement. So congested, what is the meaning? The new word congested, a technical word congested. What is the congested meaning? It is very simple. If a switch, we already know the store and forward concept. In store and forward concept, the switch continuously receives the data and stores in an internal buffer, and after some time it transfers all the data to network. But what happens if 100 system or some 24 or 25 system sends a continuous data to switch? Then in that case the switch buffer becomes full and it start to drop the packet. So in that case the congestion happens just like our road traffic. Then we have a third requirement, that is support for common service. So what is the support for common services? What's new? The picture looks cool. There is a single line goes between one application to another application. Here we have one clue for a small question. Who places these requirements on network? So here the word application to application communication path refers, this is placed by the network application designer or application programmer. Support for common service. So what is mean by support for common service? It is very simple. If an application programmer wants to create an application that sends data to another nodes in a computer network. So one way of writing the application is writing the complete codes or writing the complete code in each and every application. The another technique is writing the send model and writing the receive model, and simply in the next application integrating this send and receive model will solve the purpose. So that is called support for common services. It is nothing but our function in our programming languages. So the common services like send and receive are supported with the help of APIs. So we can write APIs for that, or we can fetch the API to send and receive the data. So that is called support for common services. There is no need to write the code for send and receive every time. So this is for support for common services. Here, application to application communication path or a pipe is nothing but a common service that is written by the application programmer, and again if a same application programmer wants to write another application, he can use the same line. So the process is very simple. It is hiding the complexity of underlying communication just like our clouds. So the first step in supporting for common services is identifying the common communication pattern. What is the communication pattern? Normally, the web page accessing communication pattern is client server model. The client is your web browser who actually requests a web page from a web server. So that is called client server communication pattern. Then we have two types of communication channel, request reply channel and message stream channel. The request reply channel is used by web pages and other simple applications. Then what is message stream channel? The message stream channel is used by other two classes of application, that is real-time audio and video, and streaming audio and video. So in real-time video and streaming video, we are not going to send any replies. Simply, we just in a one time we simply ask the server to send a block of or group of data to our server. Then the server continuously going to send the data. But the scenario is different in request and reply channel. So the first step in supporting a common services is identifying a common communication patterns. The first pattern is the client server model, and in a client server model we are going to create a two channel, that is a request channel and a reply channel. The message stream channels are mainly used to video streaming applications. So once we create a channels for this two, automatically we can use this channel for other applications n number of time. So that is called support for common services. Then reliability, that is very important. So what is mean by reliability? It is very simple. Our network should transfer the data from one place to another place without any errors within fixed time. That is called a reliable network. I once again repeat this. What is mean by a reliable network? It is very simple. A reliable network is a network which transfers the data from one place to another within a fixed time without any errors. So what are all the possibilities of errors? The first possibility is bits are lost. That is, it creates a bit errors. The 1 may be turned to 0 or 0 may be turned to 1. Then we have burst error. Sometime due to heavy traffic there is a chance for burst in packets. Then we have another physical problem, that is link and node failure. Today, almost it is practically not possible to assure the links and node failure. There are hundreds of causes for this links and node failures. Then we have another problems. Messages are delayed due to underlying cause. Finally, security issues, that is third party drops. So our network should capable of handling all this problem. So practically it is not possible to create a network without this problem, but still our network should be capable of recovering these problems as soon as possible. So in the next video I am going to explain about a network architecture, and thanks for watching this video.